Okay, so now we're gonna discuss about the derivative of the power, right? So I have the rule. The rule is, let's say y equals e power x. The y accent or dy dx is equals to e power x, right? And it is a natural number. And again, if I have e power fx or e power function, the rule of the derivative will be e power functions of x times the derivative of the power. Okay, so what we can do now for number 3, or yeah, number 3, 2 and 3. So 2, we can use the product rule, right? So x times e power x. See, I put the dot. Product rule also, product rule also, product rule, and quotient rule, right? Because it's the power, I mean the fraction, it has the fraction as well, quotient rule, and this also the product rule. So everything can be done easily. So we can go for number 3. Number 3 and number 2 is quite same, but what is the difference? The difference is asking you for the value of the tangent, right? The gradient. So for question 3a, for example, I have y equals e power x plus 2 power 4. It's still simple. We don't have to look at the x first later on. What we need to do is try to derive dy dx or y accent, right? So we use the chain rule. See, it is the function to the power of something, right? So we use the chain rule. Chain rule. How do you use the chain rule? So we have to determine the u e power x plus 2. The u accent is the derivative of e power x, is e power x itself, as it is given on the rules here. It's special for the natural log or natural number. So what next? We can do the chain rule. So n, put the 4 times u power 4 minus 1 times u accent, right? And then, okay, I use the other color. So y accent equals, wait, I don't have to put the equal sign here, equals 4 times e power x plus 2 to the power of 3 times e power x, right? This is the equation of the gradient, or I can just simplify e power x, I put here to the left side, e power x plus 2 to the power of 3 y accent, and you can put, or you can substitute the x as 0 in the equation. So when you inject x equals 0 or substitute x equals 0, so why it is 4? Y accent equals 4 times e. I do it super slowly, right? I just substitute all the x by 0. E power 0, anything to the power of 0 is 1, right? So 4 times 1, 1 plus 2 power 3. So 4 times 3 cubed is 27, right? So it is 108. That's the gradient. Okay, how to do question number C? We have the value of x, right? So B is also the same, but let's go to C. Interesting. We have 2x here. Okay, so if we have 2x, we use the second rule, right? Because e power functions of x2 times x, not x itself. So you use the formula slowly but sure. So I just rewrite 3c for the y. I put the power e power 2x plus 10 power half, right? Oh, I think I need to make the lighter pen. X equals learn 3 later on. We can skip that part for a while. So the let u equals e power 2x plus 10. So the u accent is, be careful, e power 2x itself, but don't forget to times by the derivative of the power by 2. Because if we have e power fx, the derivative is e power fx times times the derivative of the power. So this is the rules. Okay, so the rule that connects this is bottom part plus 0. Why? Because 10 derived to 0. So the u accent will equals to 2 times e power 2x. Okay, so what next? You use the chain rule, the regular chain rule. So the y accent is equals to half be careful. I have to be careful about this chain rule. The chain rule. Half times e power 2x plus 10, close the bracket, half minus 1, negative half, times by the u accent, 2 e power 2x. And then you can cross out. So e power 2x plus 10 to the power of negative half times e power 2x. And you insert the x by ln 3. So you have to understand that if I have this kind of question, this is not 0, so not as easy as previous, because we just insert the 0 and you will get anything to the power of 0 equals 1, right? So in this case, we don't use that part. You have to memorize the formula. E power ln x, wait, e power ln of a number itself, for example, n or m equals to m. We can prove with a calculator. Okay, I will show you how to prove this with calculator. This is the rule. I think your teacher is supposed to teach you. If not, it might be a huge problem to solve this kind of equation. Okay, let's see. If I have e to the power of ln 5, the answer is supposed to be 5. Okay, e to the power of 100, 1000, 1000 itself. So if I have e to the power of ln of something equals m, right? The ln of something equals to something itself, the number itself. So you have to do it super slowly. E to the power of 2 times ln 3, right? Because the question is ln 3 plus 10. Or if your teacher don't teach you this, you can just insert to your calculator. E power 2 ln 3. Again, we don't have the 2, right? We have 2 here. This is the problem. So if we don't have the 2, you can put it on top, on the edge of the 3. So you can just switch y-axis. And this is the logarithmic rule. I don't know whether your teacher teach you this, but he's supposed to teach you about this. 2, you put 2 on the root, I mean the square or the power, plus 10 to the power of negative half times e ln 3 square. 3 square is 9, right? So you just can change 9. So we can simplify. E power ln 9 is 9, right? So 9 plus 10 to the power of negative half times 9. Okay, so 19 to the power of negative half times 9. You can find with calculator. You can find the answer. I think you better use calculator because 19 power half is not a good number. Negative half, right? And then put the right side, right twice times 9. That's the answer. 2.06. 07, I think. Yeah, you do the rounding, right? 06. Oh, 064. So 06 itself. Get the idea, Tedra? So you have to do it super slowly and supposed to be so careful, very careful.
Can you screenshot that and so I can study it later?
Yeah, sure. I will copy this and I will send the YouTube to your link, to the link later on. Okay, so I put it on Microsoft Word. Oh yeah, by the way, what else? Do you have any question for this exercise? What number?
I don't think so.
Okay, good. Oh yeah, by the way, when tangent is horizontal, the gradient is always 0. Okay, horizontal line is 0 gradient. Vertical line is undefined gradient. Okay, I think it will be clearly seen. Yes. Okay, what else? What number? So let's go to the next part. Trigonometric function. I mean trigonometric derivatives. Here. Oh, logarithmic first. So if y equals ln x or natural log of x, the dy dx is always 1 over x. As simple as that. Or I will give you the simple way. This is quite hard to be understood, right? So if ln become 1 over, right? But how about the ln? I just read this as ln, yeah. Ln functions of x. If ln x equals 1 over x, the ln function of x is simply 1 over fx multiplied by the inside. See, it's the same, but more understandable, right? It is comparable from top to bottom. See, sorry, I should put this. This is y. This is y axis. Okay, better this than this, in my opinion. Again and again, in my opinion. Okay, so you don't have to get confused by where's the fx and x comes from. The chain rule. This is chain rule, by the way. Yeah, chain rule, right? So 1 over this times the inside, right? So this is the further version of chain rule. The further version of chain rule. Yeah, let's see for the questions. Okay, this is the rule. See, n below. If I have a power n, you can put the n below on the left side. See, as what we already discussed on the previous question just now. Okay, 13J. What number tedra you want me to discuss? Might be this. 3. Sorry. I think number 3 is quite challenging because we have to deal with all of our previous logic, previous rules. Let's see question A. Y equals natural log of 1 minus 2x to the power of half, right? So we need the memorization of, if I have y equals ln of fx, the y-axis is 1 over fx times the chain or the derivative of the inside. Okay, so 1 over 1 minus 2x power half, right? This is 1 over fx. You multiply by the inside. The inside is -2. That's it, right? The -2 itself. Again, if you have any problem, just cut my explanation and let me know what is your difficulties. That's for number 1A and 3A. Now, 3F, jump. Y equals ln x squared over 3 minus x. Okay, so first thing first, this is the fx, right? The one that I circled in red is the fx. So y-axis equals 1 over x squared over 3 minus x times by the derivative of the inside, right? I use the green color now, the inside. So this is the quotient rule. You need to do it separately first. U equals x squared, v equals 3 minus x. Okay, the quotient rule will be like this. So the y-axis equals u-axis v minus uv-axis over v squared. Remember this rule. I hope that you still remember this. And try to do it separately. Why I have to do it separately? To make the questions keep intact, so we don't mess up with the question. U-axis is 2x, and v-axis is -1, right? So you just write u-axis v minus uv-axis minus over v squared. So 2x, 3 minus x, right? Minus, okay, -1 times x squared is -x squared, right? Minus will become positive later on. 3 minus x bracket square, right? You can go forward. 6x minus 2x squared plus x squared over 3 minus x bracket square. That's the answer, or the inside, right? The inside, the derivative of the inside. 6x minus x squared over 3 minus x bracket square. That's it. So you put it here. 6 minus x, oh sorry, 6x minus x squared over 3 minus x bracket square. And 1 over this, the answer will be switch. You just do the reciprocal, right? So 3 minus x over x squared. Oh, we can cross so many things, so many numbers, so many variables. I get rid of the x, 6 minus x over 3 minus x bracket square. See, what I can cross is this. Top and bottom. Top and bottom. So The final answer will be 6 minus x over x bracket 3 minus x. That's the final answer. So you have to put this back to the inside here. 1 over f. Oh, wait, I think I need to put it like this. Okay. This is, okay, I don't have space. This will be, oh man, this will be 1 over fx. This will be fx and x, right? Can you imagine where you have to put this? Ln fx. You put the fx and x on top and the fx bottom. You will be so messed up, right? The fraction over the fraction, it will be messed up. But in my opinion, you better just change the position. 1 over fx multiply by, it's the same by the way, and it is more linear. This is the better display. Okay. Get it, Tedra?
I think so.
Okay, nice. So let's go for number I is the same. H. I is the same with the number or the question F, right? It's quite similar. H. So y equals ln x times x squared plus 1. It's clearly seen. It's the product rule, right? But we can simplify. Before we do the product rule, I think we better make it the more simple way. X cubed plus x, right? And you don't have to do product rule at all. You just derive properly, usually. So y(xn) equals 1 over fx, right, times fx and x. So 1 over this, or let it be x squared plus 1, right? You just go for the original one, times by fx and x will be 3x plus 1, right? Here. Okay, 3x plus 1, and then you are done. So y(xn) equals 3x plus 1 over x cubed plus x. That's it. Okay. So we have to practice. You have to practice more and more about this. Okay, I will send this to you. Do you have any more question for this number 3? Just request, or we can skip. You can pick 1 or 2 numbers. All good?
Can we do, wait, can you zoom in a bit?
Okay, zoom.
Can we do G?
G. Good choice.
Yeah.
Nice choice. G. And later on, you try to do C. We have the E. Okay, so let's do G. Yeah, I expect you to ask C and E, either C or G or both. Okay, let's go to question 3G. Sorry for this bad arrangement. Y equals ln. Oh, okay. 3x minus 4 cube close. Okay, so y(xn) equals 1 over fx times fxn x. So we have the fx or u. Okay, we can just put u times uxn to make it more simple, as simple as that. So u equals 3x minus 4 cube. So you have to do it separate in a separate part. So the uxn will using the chain rule, right? Because a function that is powered by something. So 3 times 3x minus 4 power 3 minus 1 times the inside times 3. Okay. So the uxn is 9. 3x minus 4 square, right? And I just put it like that to make it simple. 3 times 3 on the edge of the 3, on the edge of the equation. Just combine it. 1 over u, 1 over 3x minus 4 cube, right? This u and this u are the same, right? Times by uxn. There you go. 9, 3x minus 4 square. And we can just look at the simplest way. Oh, you can cross this. See, cross out, become 1, cross everything, right? So 9 over 3x minus 4. That's it. Okay, so 1 over this, everything. This is the u, right? Times u accent. The u accent using the chain rule, CR. I just write CR, QR, PR, QR, quotient rule, PR is product rule. And that's all. Okay. Do you want me to discuss, to explain you about question C, or you can do it on your own? Because it's quite simple, e power x. We're just combining the previous topic on natural number. No need, yeah? Sorry? Wait, I think your connection is unstable. Your voice is quite laggy.
Can you explain it?
Oh, okay, sure. I think you can type it later on because your voice is laggy. I don't think whether it is my connection or your connection, but in my Zoom, I don't have the info about unstable. Okay, let's do C. Yeah. Okay. No need to worry because I am recording the meeting, so you can just watch anytime after this. Okay, let's go for question C. Y equals ln square root x. So the y accent will 1 over fx or 1 over u times u accent, right? The u is this. Or I can simplify the u by e power x times x power half, right? So we use the product rule. The product rule is, okay, we cannot use another u. We have to use the other version. Let's say v, this is w, right? So the v is e power x. So to make it more to make you more, what do you call, you cannot mix the u, right? You just use the other version. V accent equals e power x itself, right? W is x power half. The w accent is half times x power negative half, right? So the u accent will equals to v accent w plus v w accent. So this is the chain rule with the other variables. So v accent w plus this. Okay, I just put a half in front. Okay, so put it below. Put it on the left side. 1 over e power x times square root x, right? Times e power x times x power half plus half e power x times x power negative half. Okay, that's all. I don't think you need to expand further, but if you want to expand further, it's better for the multiple choice part. E power x times square root x times e power x times, I just changed this into square root x plus half e power x over square root x, right? So because this is negative, so we can just do the cross multiplication, I mean the rainbow multiplication. This is 1, right? Plus this is 1 over 2x. Okay, we can cross the e on top, and square root x times square root x is x on the denominator. This will be your final answer. See how satisfying it is. Okay, so do you have any questions so far, Tedra, for part C?
I kind of understand it now.
Okay, good to hear that. Why I have to open this using the rainbow rule? Because I know that every number, every question will about the e power x will give you the satisfying answer, or it satisfy my OCD. Okay, so that's the answer. Rather than you put e, you can ignore all the e anyway. Okay, So I will send this to you also. Okay, let's do for the next part. Okay. Gradient e power where x equals e. Okay, you can use it like that, e power 1 and so on. Derivative of trigonometric functions. Okay, so I will give you the simple way to memorize. First thing, if y equals sine x, the y-axis is cos x. If y equals cos x, the y-axis is negative sine x. Where does it comes from? Again, if you ask me where, I don't know. I honestly, I don't know. But just memorize. How about tan x? Tan x is secant square x. How can it be secant square x? Anyway, you need to memorize only 2, but if you want to memorize 3, that's better for your efficiency. But if you want me to derive tan x is anyway sine x over cos x, right? This is what we know previously. And this is u over v. Let u be sine x, let v be cos x. So it is a quotient rule. I put the u accent, sine x is cos x, right? The derivative or the derivative of cos x is negative sine x. And using the quotient rule, the y accent, let's say the tan x is y, right? U accent v minus u v accent over v square. Just put it cos square x, right? U accent times v, cos times cos. Cos square x minus negative sine square x, right? Over v square, cos square x. Cos square x minus minus, or it can be plus. This is another rule, 1 over cos square x, right? The memorization, sine square x plus cos square x equals 1. So 1 plus 1 over cos square x is secant square x. See, that's how it derived. But again, rather you use the quotient rule, you better memorize this part. This will help you a lot in order to solve almost everything about trigonometric function. And we also have the chain rule. Here you go. So if I have y equals sine of fx, the y-axis is equals to sine becomes cos, multiply by the derivative of the inside. Okay. How about cos? It's the same. Or I can just write cos u, up to you. Yeah, cos u. U is also treated as a function, right? We know that u is a function also. I just use another perspective. So y-axis is negative sine, right? Multiply by u-axis, right? By the inside. Again, chain rule in trigonometric rules. Okay. Y equals tan u or tan fx. I go back to the basic part. So the y-axis is equal to secant square function of x multiply by inside. Okay. So everything's supposed to be the same. Let's see here. There you go. Okay. It's the same. Totally same. Okay, using the chain rule in trigonometric perspectives. Okay. Second derivative is also the same. It's the same, totally the same. Why? Because you just derive the first derivative. Okay. You go further. Okay, let's go to exercise 13K. I will copy this first. Wait. Okay, I will erase this. I'll design it to your I already put it on my Microsoft Word. What number you want me to discuss, or you want to discuss? You want us to discuss? 1, 2, 3, or what point? You can pick as much as you want.
Maybe you can pick a few problems. I'm not sure which one I want to focus on.
Okay, I will pick the hardest, yeah, because I know that you can do the simple way, the simple questions. Okay, so I'm trying to find the question that is challenging to both of us. Okay, because this is quite new for me also. I don't teach this, and I haven't teach this. So 2A1, oh no, I just circled the letter. I think it's too much. Wait, here. There you go. Wow. Okay, 5 number. 1B. From the simplest to the hardest. This is the regular derivative. Sine becomes cos. Cos becomes negative sine. Right? Done. Or you can just simplify like that. F. This is the 5x. So again, be careful. You have to put the chain rule. Y accent tan becomes second square. No, second square. Still 5x times by the inside. 5. Okay, using the chain rule. So for number 1, piece of cake. Easy peasy. Number 2. E power x times cos x. Man, this is product rule. Surely it's sin. U equals e power x. V equals cos x. U accent is the same because E, that's the rule. Thank God it's the rule. Then V accent will be negative sine x. The product rule formula, I just rewrite U accent V plus U V accent. There you go. E power x times cos x plus. I'm dilemma. Why? Because I tend to put negative in front. So the sine x will be like that. Okay, and I think you're okay with that, right? E power x bracket cos x minus sine x. Done. Now, okay, number 2C is quite much. 2k sine x over x. Okay, the u, wait, what I'm writing? U equals sine x. We use the quotient rule. The v equals x. The u accent is cos x. The v accent is 1. Okay. So the y accent, u accent v minus u v accent over v squared. See, it's piece of cake. Cross x times cos x minus sin x over x squared. Done. Okay. I don't think we can simplify this further. Yeah. And that's all. Now, again, it depends on the rule. So the further the question, the more complex, the more complexity it will be. It will give h, 3h. Wait, y equals. Wait, so I have to write it more neatly. Y equals cos cube for x. Again, this is quite tricky. Why? Because cos cube is the in the cos, but you can just simply put like this first. Cube, right? I can do this. Yeah. So you use the chain rule. So y equals 3 go down times cos 4x to the power of 3 minus 1, right? Times by the inside. Cos 4x become cos 4x becomes negative sine 4x times the inside again, the double chain rule. See? 4. This is the regular chain rule. And this is the trigonometric chain rule. See, this will be the trigonometric chain rule. Okay. You need to focus here. I want to repeat one more time because I'm quite surprised with this kind of question. So first thing first, the first chain rule will be like this, right? If y equals u power n, the y xn equals n times u power n subtract 1 times u xn, right? So n is 3 cos 4x to the power of 3 minus 1 times the u xn, the derivative of trigonometric function. Okay, I will use the other color, green. So cos 4x, what is the derivative of this? See, so negative sine 4x times by the inside. So I can just write 4 times negative sine 4x. So 3 times 4 is negative 12. Yeah, 3 times 4 times negative 1, 3, 4, and negative. So negative 12 cos square 4x. I put back the power 2 in the cos times sine 4x. Done. If you think that this is quite you don't get you are confused with this kind of question, let's prove using the derivative calculator. Wait, this is the powerful tools. Okay, let's see. Oh, it can be sine. Good. Cos cube 4x. Cos 4x cube, right? Go. See, cos cube 4x. Go. Calculating, calculating, calculating. There you go. See, it's same. So you can find derivative dash calculator.net. That's so cheap. See, it is same. Cos square 4x, or you can just write this. Cos 4x bracket square, it's the same, yeah, no problem with that. Okay. So any problem so far, Tedra?
No, I don't think so.
Okay, nice. Okay, do you have the homework? What homework that you want to be discussed with?
The homework you did with Vicky is the one that's due tomorrow, so I don't think so. But
Okay.
we have something to do before our test on Friday. But we can do that together with Vicky tomorrow.
Okay, sure. That's good. We still have, by the way, we still have 10 more minutes. Do you learn about the double derivatives? I think it's very simple.
We did, but like it's kind of complicated
Easy.
sometimes because it's a lot.
Complicated when we deal with the u over v, the quotient and product. Let's see this. Very annoying for question 1D. Why I can say that's annoying? Because it will be double derivatives of the quotient rule. Okay, that's what the best saying. So the first derivative, okay, you put u, okay, you have to write down first derivative, first dy dx, right? So the u is 2 subtract 3x. You use the quotient rule, right? Okay, I put this naming for the sake of easiness. V equals x squared u xn, right? Is -3. The v xn is 2x. And for the first derivative, or dy dx or y xn, is u xn v minus uv. I'm the guy that always write down this. So first, I can model the question. Second, when I teach, students also can see what I'm doing rather than I just write 3. So can you imagine if I don't write that? Wasting, it's so wasting energy. Wasting time is better than wasting energy, in my opinion. Subtract 2x, 2 minus 3x, right? In this part, it's quite easy, so I just go like this. And this part is quite hard, so I just open over v squared. Okay, I think I can do x power 4, but I keep like I keep the way long. Okay, so negative 3x squared minus 4x open bracket plus 6x squared over x to the power of 4. See, this is the first derivative. Haven't get the second derivative yet. It's annoying. 3x squared minus 4x over x power 4. So the second derivative is d squared y. This is only the sign, dx squared, using the same quotient rule, right? So what is the u? The u is here, the new u, 3x squared minus 4x, and the v, x power 4, right? Put it a bit on top. U accent will equals to 3 times 2 using regular rules, 6x minus 4. The v accent will be 4x cubed, right? And what next we can do? Okay, rewrite one more time. Let me know when I did minor mistake, because I oftenly did the minor mistake in this part, especially if the number is so packed and it's so little, the small letters and so on. Please let me know whenever I did something wrong. This, I put the x power 4 in front to make it more easy to see. Put the bracket, right? Because you have to multiply everything later on. Subtract. This, I put the v accent in front. Why? Because it's more simple to be written rather than this. 3x squared minus 4x over v squared. Square, right? So 6x to the power of 5, do the rainbow rule, minus 4x to the power of 4, subtract 12x power 6, sorry, 12x power 5, because power times power becomes plus, and then minus 16x to the power of 4 over x to the power of 4 power 2, not 6, yeah, but 8, multiply. So negative 6x to the power of 5, combine the like terms, minus 20 x to the power of 4 over x to the power of 8. And we can do further. One more step. Get rid of the 4, right? Negative 2. So 3x, right? Minus 10, no, plus 10 over x power 8. And we can do one more time. Sorry, it's not one more step, 2 more steps. 4 and 8. So negative 2, 3x plus 10 over x power 4, right? Because you can cross this, you can cross this. That's proof. I'm the guy that also insecure with what I do. So let's try to solve this. First derivative, we have to do it one more time. 2 minus 3x over x squared. Right? There you go. Go. What's wrong? Oh, no. There you go. Okay. It's different, but again, you know what thing? I did something. No, I don't do something wrong, but I did something less efficient. How about if the first derivative, I want to simplify this by get rid of the x. Right. Oh, this is way easier, right? Can cross this, becomes 3. So you learn from my mistake, yeah? Don't do what I did just now. So we can do this. And we will have the more simple u on the second derivative. See why I have to do this? Why I have to put this in total? Since I can simplify. So simplification is essential in this part. How about if I use this to do the second derivative? I just use u as 3x minus 4, and the v is x cubed, right? It is way more simple than this. Okay, we will get the same answer, by the way. It's a matter of efficiency. Okay, no problem, yeah, Tedra, I will give you two ways. First is the non-effective way, non-efficient. Because I do this, but in this case, I do this part. When I simplify, it will be more easily to be seen and done. 3x squared. Uxn v minus uvxn over v squared, right? 3x cubed. See how easy it is. Minus 3x squared, I put it in below in front. 3x minus 4 over v squared x power 3 power 2. And then 3x cubed. See? Oh, okay. It's very, very simple. 9x cubed plus 12x squared over x power 6. And then negative 6x cubed, right? Collect the like terms, plus 12 x squared over x power 6. Wait, did I do something wrong? It's supposed to be same, by the way. Why? What's wrong? What's wrong? What's wrong? Okay. See, Tedra, look at the middle part here. I did one minor mistake. Negative 4x cubed times negative 4x squared. Negative 4x is negative 16x power 4. It's wrong. See, it's supposed to be plus, and it has to be plus 12, right? See, the more complicated the number, the more detail that I can miss. Okay, the more silly mistake that I can do. So please don't do like what I do just now. And negative 2 x power 4, so it is minus 6, right? Minus 6 here. Okay, I can just go here. See, when you look at what I did, you can see how not efficient it is. You have to do all over again and check one more time x plus 2, right? And then this is supposed to be not like this also. Okay, so this is same, so negative 6 x plus 2 over x power 4, and it will be the same. See, the more simple, the less mistake that you can do. Okay, negative 6 x squared, so x minus 2 over, wait, did I do something wrong? Okay, wrong. See, minus, another mistake. Okay, there you go. So you can learn from my mistake here to do like this. Totally avoid that x power 6. Okay, so you can cross this 2 and becomes x power 4. So negative 6 x minus 2 x power 4. This is more efficient, way more efficient. Okay. Here, I simplify. That's the problem. Okay. Use this. Let's try to prove the second derivative. Yeah. Okay. I will give extra time for some time. Here. Try to use the top side. 3x power 2 minus 4x over x power 4. Okay, I use the non-efficient way. Go. The answer is this. Wait, let's prove. Yeah, it's the same. Yeah, by the way, you can just put the negative out of negative 6x minus 12. See, and yeah, surely we'll be same with this. Okay, so they just don't factorize the number, the numerator part. Okay, that's all what I can teach you for today. Any other question, Tedra? For last chance.
No, I don't think so.
Okay, I hope you good luck for next your test. So I'll see you on tomorrow at 4, yeah. Okay, Tedra, with Vicky.
Okay.
Okay, so I'll see you tomorrow. Bye, Tedra.
Okay. Bye. Thank you.
You're welcome. See you.